Today we will be discussing how to do some wavelength and frequency calculations. My first example problem says that red light has a wavelength of 720 nanometers, and I'm asked to find the frequency. I know that I have wavelength and frequency, and my equation that relates both is C is equal to lambda nu, where nu is my wavelength of 750 nanometers, and C is equal to the speed of light of 3 times 10 to the 8th meters per second. I need to solve this equation for nu. I see that lambda and nu are being multiplied, so to solve for nu, I have to divide both sides by lambda. That will cancel it over here, leaving me with the new equation of nu is equal to the speed of light divided by lambda. A thing to note in my equation is that the speed of light is in meters per second. However, my lambda right now, my wavelength, is in nanometers. This is not an appropriate unit, so I do need to convert this from nanometers to meters. So I'm going to do a quick dimensional analysis to do so. So I'm looking for how many meters are in 750 nanometers. I know that every 1 times 10 to the 9th nanometers is equal to 1 meter. Nanometers cancel. So I would just go ahead and plug that in. So 750 times 1 times 10 to the 9th, or E9, that gives me, or I'm sorry, shouldn't have multiplied that. Should have divided. That gives me this number. If I was to convert it to scientific notation, one, two, three, four, five, six. That would give me 7.50, because I'm not 0. 7.5 times 10 to the negative 7th. And this is meters. So then I have that my frequency, my nu, is equal to the speed of light, which was 3 times 10 to the 8th meters per second, divided by my wavelength, now in an appropriate unit, 7.5 times 10 to the negative 7th meters. Meters cancel. And so I can go ahead and plug that into my calculator. So 3 E8 divided by 7.5 E negative 7 gives me the frequency of 4 times 10 to the 14th. And then my unit, the only English left in my math, is 1 over seconds, or hertz. And that would be my answer. My next example problem says a radio station broadcasts at 590 kilohertz. What is the wavelength? So I have my frequency in kilohertz, and I'm asking for wavelength. So my relationship is the speed of light is equal to lambda nu, where my frequency is 590 kilohertz, and my speed of light is 3 times 10 to the 8th meters per second. kilohertz, otherwise known as hertz is one per second, so kilo per second. I need to convert this out of kilo and into just normal hertz. So I'm going to do a quick dimensional analysis. So how many hertz are in 590 kilohertz? There are 1,000 hertz in 1 kilohertz. So I would multiply 590 by 1,000. The number's not gross enough for me to convert that to scientific notation, though you could. So now I have my C is equal to lambda nu, and I need to solve for wavelength, so I need to solve for lambda. So C is equal to lambda nu. I'm going to divide both sides by nu, since nu is currently multiplying my lambda, and that will leave me with lambda is equal to the speed of light divided by my frequency. So 3 times 10 to the 8th meters per second divided by my frequency, which was that 590,000 hertz, which remember is per second. If I'm dividing by a my unit is in the division sign, so it's actually going to flip up. So seconds will flip up, seconds will cancel. And I can go ahead and plug that into my calculator. So 3E8 divided by 590,000. So 508.4745763 is the number that I got out of my calculator. And I'm going to maintain sig figs. I have 2 sig figs here, so 1, 2, 8 makes me round up. So my answer would be 510 meters. My next problem states a low frequency radio wave has the frequency of 250,000 hertz. What is its wavelength? So I have frequency and I have wavelength, and the relationship between frequency and wavelength is C is equal to lambda nu, where my frequency was that 250,000 hertz, and C is equal to the speed of light at 3 times 10 to the 8th meters per second. Hertz is already appropriate. Remember that hertz is per second, so I'm already in an appropriate unit. So actually the only thing that I need to do is go ahead and solve the equation for lambda. So I see that lambda and nu are multiplying, so that means I just need to divide both sides by nu. And that will allow nu to cancel, leaving me with the equation lambda is equal to the speed of light divided by nu. So 3 times 10 to the 8th meters per second divided by 250,000 per second. So that second will flip up. Seconds will cancel. And I can go ahead and solve that. So 3E8 divided by 250,000 gives me the number 1,200, and then I'm in meters. Very last problem that I will need to do. I have that a certain microwave has a wavelength of 0.032 meters, and I'm asked to calculate the frequency. So I have wavelength and frequency. The relationship between wavelength and frequency is C is equal to lambda nu, where my wavelength is equal to that 0.032 meters, and my speed of light is equal to 3 times 10 to the 8th meters per second. Meters is already an appropriate unit, so I don't need to convert out of it. So the only thing that I need to do is go ahead and convert or rearrange my equation so that I can find nu. So I have the original equation of C is equal to lambda nu. Lambda and nu are being multiplied, so all I had to do is go ahead and divide both sides by lambda, and that will give me the equation that nu is equal to the speed of light divided by lambda, and then I just had to plug everything in. So I have 3 times 10 to the 8th meters per second, and then I have my lambda at 0.032 meters. Meters will cancel, and I am left with per second, which is an appropriate unit for frequency, so I can go ahead and plug everything into the calculator. So I have 3E8 divided by 0.032. That's a really long number. 6. I'm going to go ahead and convert it into scientific notation, maintaining sig figs of 2 sig figs. Two sig figs, not 2 decimal places. So 9.4 times 10 to the 9th hertz.